Hey everybody, and welcome to the next video of the course. This video focuses on one topic, the topic of lists. How do you create a list in Python and what do you do with it? I should at this point say that in programming itself, there are some tools that are just extremely useful, extremely powerful, and come up all the time. The first such tool that we dealt with was an if statement. Conditional statements are incredibly useful, and real programming is impossible without them. A list is another such topic or tool. Real programming cannot be done without lists. So this is sort of our second big topic, second big tool that we can add to our Python toolkit. The next topic, by the way, that we will see is a loop. So when we get to loops, those are also foundational. So the goal of this video is to introduce what a list is in Python and how you create them, and then do some basic things with them. So here's the basic idea. Here's something we're already familiar with. This name right here is a string variable, and I've stored my name in it. And as we've seen before, Python thinks of this string David McCune not as sort of a single entity, but as being composed of individual characters or symbols. So we start with a capital D, the next symbol is a lowercase a, and so on, and each symbol has its own place in the string. There's like a position 0, a position 1, etc. So what I'm saying here is that a string variable, like this David McCune, is basically just a list of characters. You have a bunch of characters that you have listed, and each character has its own placement inside of the list. So in Python, you can make a list of anything. You don't have to just stick to lists of characters or lists of English symbols like this. You can have lists of numbers. You can have lists of other people's names. You can have lists of lists. You can make a list out of anything. So let me just show you some of these things. So here's how you create a list in Python. You control the names, as always. So I've called these list 1, list 2, etc. just to be descriptive about it, but you can call them whatever. This list 1 is, I'm setting it equal to, the list consisting of the numbers 1, 2, and 3 in that order. Okay, this is a list with 3 numbers in it, and those numbers are 1, 2, and 3. So the syntax here, you have to use square braces, and then you have to put a comma in between each entry. List 2 is a list of names. There are 4 names in the list: Lori, Mary, John, Evelyn. Okay, it's a list with 4 names. List 3 is a list with 3 numbers and then 2 names in it. Okay, so again, you can make a list of anything. I don't know why you would create a list that's a jumble of numbers and names, but you can if you would like. You can make a list consisting of lists. Okay, so list 4, the first element of the list is a list itself, the list consisting of the numbers 1 and 2. The second element is also a list consisting of the numbers 3 and 4. You can also make a list consisting of nothing. That's what this list 5 is. So you might wonder, why do you create a list with nothing in it? But we will see later why that is useful. Okay, so let me hop over to the compiler and just show you some of this in the compiler. So list 1 was the numbers 1, 2, and 3. I'm going to create that, then I'm just going to ask Python to print that for me so that we can confirm that that's what it is. So Python knows exactly what that list is, right? It just prints it back out to me. It knows that list 1 consists of the numbers 1, 2, and 3 in that order. So you can add other numbers to it if you want. You can make a list consisting of 1, 2, 3, 15, -5, whatever. And now if I ask Python to print that list, it knows what I'm talking about. 1, 2, 3, 10, 15, -5, and so on. I could put a list in here like this. The list consisting of 3, 2, 1. I could put a name in there like that. So now I have a list with 8 elements in it. This element here just happens to be a list itself, and this element here happens to be a name, but whatever. So now when I ask it to print, notice what it shows you: 1, 2, 3, 10, 15, so on, and it ends with David. That's how you create a list in Python and put stuff in there. Okay. So here's our first examples of a list in Python. So the first observation to make is that lists are kind of like strings, where you have individual elements of a list, and they each have a location inside of the list. So this list here, consisting of the numbers 1, 2, 3, the first element of this list is the number 1, and the second is the number 2, the third is the number 3, and so on. This list 2 right here, the first element is the name Lori, the second one is the name Mary, and so on. Okay, but just like with strings, and this was annoying, right? Or I think it was annoying, the first element actually is not in position 1. So when I say first element, I actually shouldn't be saying that. The first element is actually in position 0. So number 1 here is the 0th item of that list. The number 2 is the actual, now first, if you like, the 1th item of that list, and then 3 is in position 2. Okay, that's just like with strings. So I have 3 things here, and the positions range from 0 to 2. And you access individual elements of the list just like you did with string. So you use this bracket notation here, this square bracket, 0, that will access the list element at position 0. So the first element in this case. And then here you can access the list item at position 2, which is 3. And so on. Okay, so let me go back to my compiler here and just show you that. Let me pare my list down. I can ask Python like, hey Python, what's the list element at position 0? And it will go to position 0 and just tell me what's there. And it tells me the number 1. Okay, so it recognizes this same notation, the same syntax from strings. Let me put a 4 in there. So 1 is in position 0, then 1, 2, 3, 4. So 15 is in position 4. It will print a 15. It knows what that is. And so on. Let me do position 6. It should know that's a, position 5. It should know that's a -5. Okay. Now, I was going to get to this in the video later, but since I made the mistake now, let me just point it out. If you try to do a 6 right there, okay, Python freaked out at me. And why did it freak out? Well, 1 is in position 0. 2 is in position 1, this is position 2, position 3, position 4, position 5. There is no position 6 because we started our positioning at 0. So if you try to access elements of a list that aren't there, it's going to yell at you, right? It's telling me here this index error. It's saying, you tried to go to a position that doesn't exist, man. You know, there wasn't anything at position 6. If I put a 10 in there, it will give me the same kind of error message. There's nothing at position 10, you know, so what do you want me to tell you? Okay, so the first little observation is just like that was true with strings, it's true with lists. You can access individual items at positions. So with this list 3 here, the 0th position contains a 5. The third position contains the name Dave. With this list 4 contains 2 elements. There's a first list and then a second list. So 1, 2 is at position 0. 3, 4 is at position 1. So if you ask Python like, hey, at position 0, what do you see? It tells you the list 1, 2. Okay, so we can now do a couple of things. We can create a list and then access individual items of the list. So if you're thinking about what a quiz might look like over this material, it would be something like this, dealing with this. Creating a list or accessing individual items of a list. Okay, so now let's move on to operations, things you can do with the list. This, by the way, also might show up on a quiz, so don't just stop watching, I guess, but I'm just saying this kind of thing is the level of question you would see. Like, what is list 3 brace 0 given this list? You should be able to tell me things like that. Okay, so doing things with lists, since a list is much like a string, then many of the string things that we've already done should work here, and that is indeed the case. So for example, you can use the addition symbol on lists, and it will just glom them together, just like with strings. So if list 1 is 157, list 2 is 9, David, list 1 plus list 2, it just gloms them together. It takes the second list and just gloms it together with the first list. So here's a new list. You could call this list 3 if you want to. So just to show you that, list 1 is already here. Let me create a new list. I'm going to put a 4, then like a David on there. I could ask Python to create now list 3, which will be list 1 plus list 2. And I could ask it to print that just to show me that it knows what I'm talking about. And it prints, notice, all of the first list up to -5, and then also the second list. So list 3 is just a combo of those two. And if you want to do them in the opposite order, you could. You could do list 2 followed by list 1, and now it starts with the for David, right? Because I'm doing list 2 first. That's how addition works with lists. That's also how addition worked with strings. Okay, so the next thing you can do is you can use this very useful function called the append function, which just lets you throw items into a list if you want to. So suppose you have list 1 is 157. If then you issue a command like this to Python, list1 dot append, and then in parentheses put a 9, Python will just throw a 9 onto the end of that list, right there. So it changes the original list. You can append things. You can add things to a list like that. So let me just clear this off here. Suppose I have this command here, list1 dot append, and then a 13. What Python will do is it will take this list that already exists and just throw a 13 onto the end of it. So the list has been changed, and now when I ask it to print, it will have a 13 at the end. Okay? So just to make this clear, let me have it print list 1 a couple of times. First I'm going to create the list and then print that. Then I'm going to append 13 and print list 1 again. Okay, notice at line 10, the first time I print this list, there's no 13 at the end because I haven't appended yet. But then in line 11, I throw that 13 in there, and now the list has been changed. And this printing over here, this outputting, reflects that. Okay, so you can throw things onto the end of a list if you would like, using an append command like we've done. You can also ask Python how long a list is, and just like with strings, the length function here just tells you how many items are there. So if list 1 is this, okay, 19, -5, and so on, let's just count the number of elements in the list, the number of items. So 19 is the first, -5 is the next one, so on. So 1, 2, 3, 4, 5, 6, 7, this entire list is just a single item of the list, 8. Okay, so there are 8 things inside that list, one of which happens to be a list itself, but that doesn't matter. So the length of this list is 8. Okay, so another thing that's kind of confusing, this was a problem with strings also, is that the positions here in this list 1, the positions run from 0 to 7. There is no position 8. However, there are 8 things there. Okay, so because we start our indexing or our counting at 0, that means we end at 7, but we end up with a total of 8 things. You can also look at sublists, just like you could do substrings with strings. So list 1 and then square brackets m:(n), just like with strings, you get the list of things that starts at position m and ends one before n. So you're inclusive on the left, not inclusive on the right. For example, if list 1 is this, then if you create a command like this, list 2, tell me what list 1 is, but from 2 to 5, not including 5. Well, 5 is in position 0, right? 4 is in position 1. 8 is in position 2, so I pick that up, position 3, position 4 right here at the 3, and then position 5 is 13, but I don't include the 13. Okay, just like with strings, I'm not inclusive on the right. Just like with strings, you can omit one of the numbers to the left or right of the colon. So if you omit the number to the left of the colon, then you're just saying we'll start at the beginning of the list and end one before the n. So again, you're not inclusive on the right. Or you can just do like this, put a number on the left and omit the thing on the right. That just starts at position n and then goes all the way to the end of the list. That was true for strings. It is still true here. You can delete elements of a list if you would like using the del operator. So this is a command here, del list1m will delete the element at position m from this list. So for example, if list 1 is this, and then you issue this command to Python, del list12, it won't delete the number 2, okay? This list has a number 2 in there, right? This 2 right here is a position. You're telling Python go to position 2 inside the list and delete what is there. So 4 is at position 0, 2 is at position 1, 3 is at position 2, so it deletes the 3. So just to show you that, with this list 1 I've already got going here, I'll do del list 1 and then put like a 3 in there, okay? And then ask it to print list 1. Let's see what it does. It prints the list 1, 2, 3, 15, -5. The 10 is gone. Why is the 10 gone? The 10 is gone because it's at position 3, and you're telling it to delete. So it's just been kicked out. Okay, so anyways, you can access substrings, you can delete if you want to. You can also delete an entire sublist if you want to. So if you issue a command like this, del list 1, start at M, end at N, it will delete everything starting at M and then up through N-1. So as always, we're not inclusive on the right. So for example, if list 1 is this again, and you issue this command to Python, it will delete the items at positions 2, 3, and 4. Okay, so 4 is at position 0, 2 is at position 1, so 3, 1, 5, that comprises positions 2, 3, and 4. So those are gone now. So as a final warning here, don't do what I did earlier in the video, where you try to access a position that is not there. Okay, so that warning has been issued. So at the end of this video, what should you be able to do? You should be able to create a list if you're asked to, right? If I say, hey man, create a list consisting of the numbers 10 and 12, or whatever, right? You should be able to write something like this. Here's a list consisting 10 and 12. You should also be able to add a list together. You should be able to access sub-lists, as we just talked about, and delete things if you need to. And that's the end of this introduction to lists. We, of course, will be using lists more throughout the course. This is an introduction, so we have not seen the full power of lists here, okay? So I said that they are foundational tools. It's perhaps not obvious from this video why they are so foundational or so important, but we will see throughout the rest of the course why they are so important.